Cool, that worked. Let's do the full screen. All right, so my talk today, and hopefully demo if things go well, is about distroless container images and why I believe they are your last line of defense against zero-day security vulnerabilities. But just before I get into it, just myself. So Andrew Dean, I currently work for ChainGuard. Before this, I spent about 4 years working for a company called SysDig, where I helped organizations kind of understand their cloud security posture and do threat detection in the cloud and Kubernetes environments. I'm passionate about cloud, Kubernetes, container security. I do have the KubeSmart badge. I got the jacket. It's just too warm to wear at the moment. I've been tinkering with Linux and open source since the late 90s, which gives you a hint as to how old I am. And then on the non-tech side of things, snowboarding I've been doing since about the same late 90s as well. Recently getting into scuba diving, traveling, point hacking. Don't like to pay for the flights, like to use points for these things and figure out loopholes there. And football, that's the round ball one. So I'm a big Man United fan, right? My LinkedIn is up here if anyone wants to connect. And these slides are coming out after, so you don't need to take photos and stuff. So to start with, to kick it off, I guess my question for anyone here is, anyone want to be brave and tell me what is a zero-day vulnerability? Yeah.
One without any fix.
Vulnerability without fix. Yeah, cool. Anyone else? It's good. So, Ash, at the back of the room, any other ideas, mate? Not quite. I work with Ash, I can tease him, it's fine. So here's some of the things I wrote down. So a software flaw unknown to the vendor or maintainer at the time. It's something where there's no patch or fix available and the attacks are happening. It's exploitable immediately. It's called a zero day because defenders have got 0 days to prepare or patch against this thing. Once it has been disclosed and patched, it becomes an end day, a known vulnerability. So this is kind of what my talk is based around and what reason I'm kind of sharing this. And we'll come back to how this fits into things. But first, I want to talk about some infamous examples of actual vulnerabilities we've seen over the last few years. Now, there's 3 examples I'm going to go through. The first one, before I go to the next slide, it's probably one of the most popular ones in the last few years, and I bet someone here can guess what the first one is going to be because all the vendors use this one. Anyone want to guess?
No.
Yeah, log4j, exactly. We all love this one. So for those of you who don't know, log4j is the library used in Java, a logging library, right? So developers can use this library in there and they can use it to kind of, handle all their logging and deal with all the configuration around that. So it was very widely used. There was a vulnerability in that library that allowed attackers to kind of send a specially crafted log, essentially, and then that would cause something else to happen, right? So in this case, and I'll go into more details in this one in a few slides, but it would just send out a request to an external server hosted by attackers where they'd send back a malicious payload. The key thing here is actually this, the picture on the left here I'm talking to is the vulnerable code for this weakness, this vulnerability was introduced into the code base in 2014. It wasn't discovered until 21. So it's 7 years of this vulnerability, this weakness sitting there, which is effectively a 0 day for that time, right? 7 days was unknown vulnerability. It was there. People could have been exploiting it. Maybe they were, maybe they weren't, but it was there and there was no patch available because no one knew about it, right? The second example I have here is Spring for Shell. So this was Spring Framework. It's a popular framework in Java. It's very common to build web apps and REST APIs. Anyone who works for a bank, I know all the banks use this stuff. This had a weakness in it, which allowed the attackers to write their own files to disk, essentially. And so what the attackers were doing was writing their own JSP file to it, which was exposed. And that JSP was basically allowing them to execute OS commands. This is known as a web shell. Once again, you can see the same graphic on the left where the vulnerable code was introduced in 2017. The vulnerability itself, the weakness, sat there for 5 years before anyone noticed it and logged it and kind of a patch was released. Last example, Spring Cloud. It feels like I'm picking on Java. I promise there's other frameworks that have problems as well, but these are the easy ones and easy to talk through. The same concept applies though. This one was in Spring Cloud framework. And so Spring Cloud is used for distributed systems and microservice. It sits on top of Spring Boot. This allowed attackers to execute code by passing a specially crafted HTTP header. And this one is a bit easier to show. I'm actually going to use this as my demo. I've got an environment set up, which is vulnerable to this weakness. I'm going to show hands-on an exploit of this. But once again, you can see the vulnerable code committed 2020 wasn't fixed until March 2022. So 2 years of this thing being around. So the theme I'm trying to kind of leave you and think about here is that all these weaknesses are in the systems today. The ones we don't know about, right? They could be found tomorrow, they could be found next week. But these weaknesses, these vulnerabilities, they exist. There's no secure system. Nothing is secure. If it's turned on, it's not secure, is my opinion. We can put defense in place, and defense in depth is a very common thing for security people to talk about, and definitely. And so patch your stuff, put in firewalls, put in WAFs, all these things, absolutely. And then when I talk about last line of defense, is this Distroless point of view. This is the story I'm trying to build up here. Any questions about those three before I move on? Cool. So this is some examples of real-world exploits that were observed and captured in the wild back during the Log4j or Log4Shell is the nickname for it. Vulnerability was out in the wild. So hopefully you can read that big enough. So there's 4 examples. These came from security researchers at Zscaler and Palo Alto Networks. So there's 2 links in there that kind of go into more detail. But I just grabbed these payloads. And what this is doing, in case anyone is curious, is that it's using the JNDI lookup inside Log4j. It's saying, hey, make an LDAP call to this IP and port. Now, this IP and port is basically a exploit kit that the attacker is hosting. And then it's passing this basic command, base64, and then what is a base64 string. All of these are doing the same thing, like as far as the way they attack. And then this base64 string decodes to something that's different for each one of these attacks. Once again, this is real world. This wasn't an example or whatever. This is something that these guys monitored and found in the wild. So my question for anyone here is that, can anyone see a pattern on something common that's in common between these 4 attacks on the screen? Say that again, sorry? LDAP, yep. LDAP is the method they're doing, correct. What about what they're doing after that? Is there anything in common about what they're actually running? Sorry? A script, yes. Spot on, exactly. So we look closely, wget, 𝐑𝐿, sh scripts, shell script, bash, shell script, bash. You can see where I'm going with this, right? Hopefully I'm setting the story. Now, just before I kind of go on, just a bit of background to what a typical attack might look like. So finding your host, Shodan's pretty famous. There's lots of other ways to do this. You can run your own scans within that, but looking for potential targets, right? IPs, target ports, you're looking for the services, hopefully the versions, you can fingerprint this stuff. They'll try and maybe attempt the exploit, can be usually automated, these things. If it is successful, so if it's the right version and it's not patched or the configuration isn't there to prevent this, they might get to the next stage of exploit, right? Success. That kind of gives them that initial access. From there, there's usually 4 things that attackers do, and it doesn't matter how they get in this point. It can be a vulnerability, can be a 0-day, can be some other way. The way you get in, it's almost like a house. You get in through a window, the door, whatever, it makes no difference. The person in your house is going to do the same thing that they intended to do. So the main 4 things attackers do: steal compute, deploy crypto miners, that is. Steal secrets to move laterally, so looking at things like AWS secrets, looking for Kubernetes tokens, looking for database credentials, anything that allows them to move laterally from where they are. There's nothing sensitive there, or even if there is sensitive, they want to find more. Steal data, so ransomware, ransom side of things, or the C2 server, so just getting a bot on there and for their bot army, whatever they're doing. They're the 4 main types of patterns you'll see once people do gain access to something. These can often be done in an automated way. Script kiddies just get this stuff, you get well-known vulnerabilities, and off they go. And the key here, and kind of coming back to the previous slide, is that there's this thing that is known in the, I guess, community, a security community around attacks, which are LOTL attacks. Anyone know what that stands for? Living off the land. Yes, spot on. So living off the land. So this is a common theme for a lot of attacks. It's basically where the attackers are using these binaries, these shells already exist in the environment, target environment, right? They don't bring their own stuff. They just come and use what's already there. This makes it harder for your threat detection to actually detect and pick up these threats in runtime, right? They can hide amongst normal things. And it allows them to script this stuff, right? A lot of these tools exist in a lot of these environments. They can just automatically run this stuff. There's a really good blog here. Once again, this is Palo Alto. There's a adversary called Team TNT, which was around back, I don't know, a few years ago, probably still around now. And these guys are targeting cloud specifically, right? So AWS and Kubernetes clusters, they're after this. And the reason I bring this up is that this is a screenshot that Palo Alto found of basically a repository of all these scripts that were running or that were used by this group to attack stuff. Once again, if you have a look closely, it might be hard to see, but these are all nden.sh. They're all shell scripts again. Right? This is what real attackers use. I'm kind of doing this on purpose. It's not me making it up. I can do that. This is real stuff. We can see things in here, right? Like, kubelateral.sh, we can guess what that's doing. xmr.sh, xmrig, it's probably installing crypto miner. There's other ones in here where they're probably just set up cron tab for like persistence, right? But the key thing I'm pointing out here is these are shell scripts. Okay, enough slides. Let me attempt to do something. I mean, these stuff never goes well, but I've been in your shoes and I much prefer to see demos and just slides all the time. So let's see how we go. I'm going to do this. Let's get terminal window. This could be interesting. Yeah, I've got a few terminal windows open, don't I? Maybe I should close some. Cool. So, actually, you know what I haven't tested? Yes, it works. All right. So this is connected to my Kubernetes cluster. I have access to it. It's not on my machine. It's all over the cloud. Let me try and make this a bit bigger. You zoom in. So let's have a look at what is here. I've got 2 pods, 2 deployments really, and 2 services. Okay. So there's this Vuln app pod and a Vuln app chain guard. These are identical applications. They're both Java applications. They're both running the Spring Cloud framework. The jar file's the same between them. The only difference is the from line, right? And in fact, let me show you. If I have a look at the actual repo these came from, this is the Docker file for the normal one. And you can see it's just using Maven. It's copying some source code. It's building it. This is the runtime stage. So it's a multi-stage build. Eclipse, Tamarin, and then copying in the jar file and off it goes. If I look at the chain guard version of this, it's identical. The only thing changed is this. I've changed the from line. So it's running the chain guard JRE latest instead of the Eclipse Tamarin public image. That's it. Okay. So these 2 images are built and they are running on my cluster here. So they've both got a service in front of them. This one has an IP of 119, the other one is 118, right? So the normal one, the standard one, is running 119. To get out of this view, hang on. So if I have a look at 119, this is the URL. This is just saying it is returning the vulnerable Spring Cloud function demo. It's a little app that I've got here. I did put a little endpoint on here called /result. And you know what I didn't do? 1 second. Just waiting for Java to start. This might take about 12 minutes. Cool. So this endpoint, the result endpoint, all it is a bit of logic to say, show me the files in the /temp directory inside the container. So rather than me trying to exec into it and show you, I'm just trying to make it a bit cleaner. And so what I'm going to do here is run some exploits against that vulnerability. All right. So on the other screen here, I'm just going to copy a command. I'm going to talk you through it. So hopefully you can see that, make it a bit bigger. Can you see that down the bottom? So this is just doing a curl. It's a post. This is the endpoint, that 119 endpoint, right? That's that standard image here. We can see it's a function router is the path. It's standard. This is what we want to exploit. -head in -h in curl is the header. Spring Cloud function routing expression. This is the standard kind of header you want to pass into this to exploit this. And then I'm passing this kind of this get runtime exec command in here. Really what matters is this last bit, bash c, who am I, pipe to temp, who am I.txt. If I hit enter, this returns in the console this 500 status error. That's expected when you actually do this exploit. But if that works, if I have a look at the temp directory in that container, here is the file that it just wrote for me running that command. And so I have a look at it, you can see it's written as root. This container is running as root. Make sense? Let's do another one just to kind of prove this. So this one, exact same kind of command, except that again, the payload is a bit different. It's just saying ps aux to the ps.txt in temp. If I have a look and go back and refresh, I now see this ps.txt, and it's showing me the output of that command, ps aux. Now we all know this isn't a container because what I showed you is running my cluster. Does anyone know easily how to tell this is a container by looking at this? What's the giveaway? This was a Linux virtual machine. What would the PID1 be? Sorry?
Usually it's zeros, right?
No, like when you start a Linux machine, you kind of have a PID1. It looks, yes, yes. So in a container, normally PID1 is the thing that you're starting, right? This is a Java app, so it's a hint to an attack. Hey, I'm in a container. They can kind of start to see these things. I'm going to now show you what slightly more interesting thing. So let's do this. And then zoom in. I'm going to run a command called netcats. It's really hard with one hand. Netcats. I know why. Cool. So what I've done there is I started standard Linux command netcat. I've told it to listen on port *444. This is going to be used for a reverse shell. Now, reverse shell is a common tactic attackers use. Basically, they can't open up a shell to the target that's behind firewalls and stuff, but you've got some other path like we do here with this exploit. I can instruct it to open up a reverse shell, tell that thing, this container, to reach back out to my shell that I've got listening here. This is normally be on the public internet, right? And so with that, what I need to do is just run another exploit, the same kind of curl. Let me just clear some of this rubbish. So same kind of payload. Difference is, I'll make this a bit wider. So we're running bash -i, and I'm piping the output to dev TCP 192.168.10 quadruple 4. That's the IP of my laptop running that netcat. Fingers crossed this works. No, it didn't work. 1 second, let me try something. Something always has to go wrong. Otherwise, it's not a real demo. So I have Tailscale set up. Anyone who use Tailscale? It's quite good. So this is just kind of tunneling all my traffic from my devices to each other. I'm just looking for my tail scale IP. Do it this one. No. What would happen is a reverse shell would open. I would literally have a terminal in this window, which would be inside that container. And the plan was to show you, if this works, is actually, I can back up. Boom, there we go. So this was the reverse shell. I just SSH home. And now this root at Volnap, this is a shell inside my container, right? So this machine I'm on has nothing to do with that Kubernetes cluster. It's external to it, but the shell is opened up. If I go and start having a look around, you can see there's the app jar. I can have a look at that temp directory to see those files that I was writing before. So we can see who am I and PS, they're here. I can look at the mounts and start to see what's going on in here. So we can see this is a container. Since this is running in Kubernetes, we can actually see the service account directory here. Anyone know what this might contain, this directory? Yes, spot on, tokens. So I now have a Kubernetes service account token. So I can now use that to pivot, like I said, move laterally. It depends what permissions this is running as, right? But you can start to see the type of things. I can run curl and wget and start downloading crypto miners. That's that last stage of the attack I was talking about before. All right. That's kind of the anatomy of what an attack might look like. Now, getting to my point is that how does Distroless help against this, right? So yes, this is a known CVE. I don't have a real zero day to show you and test with here, but the way you get access doesn't matter. Just kind of understand it's exploited a vulnerability. I'm going to do the same thing now against the other container, the one that's running chain guard as its base image, right? So Distroless image. Does anyone know what a Distroless image is actually? I probably should have touched on that right at the start.
And your container runs just with the binary software program.
Yeah. So basically, if you didn't hear that, it's containers run applications. Applications don't need a whole Linux distribution to run. They don't need a shell. They don't need curl. They don't need a package manager. They don't need Git. All these extra things that come with a Linux distribution. I mean, if you start with the public node image, it's got Python installed because that's what Debian comes with, right? That's not Distroless. That's a distro. It's a full Linux distro that forms most of these containers. So Distroless is basically saying, well, I just want the bare minimum packages to run this thing. So if it's a Node app or a Java app in this case, you only need about 20 different OS packages to run. You don't need all those package managers and shells, okay? So the version I'm running, and there's not just ChainGuard that does Distroless, but Distroless in general is going to help here. So I'm going to prove it. So this is the service, the 118 is the one that's running the other container. I'm going to run exactly the same exploits against this one that you saw me do. So different IP, exact same exploit. Who am I? I get this result, 500. We saw that before. It looks like it worked. The exploit technically did work. It got in there. However, if I go and have a look at that folder here and try and look at it, there's nothing in here. So while the exploit worked, the command failed. Now, the reason the command failed is because I'm calling a shell to try and do this thing. All these commands, they need a shell. And because there's no shell, it fails. And I can prove that as well. We look at the Kubernetes logs and I can scroll back and I can see here, exec failed, no such file or directory. It didn't have the thing that I tried to execute. Right? This is the whole point of this is that if I don't have a shell, I don't have a package manager, don't have all these binaries, back to the living off the land attacks where they're expecting all these things, you make it so much harder. It's not impossible. I'm not here saying that no one can hack a Distroless container, You just made it 95% of these attacks go away, whether you got a vulnerability or not. Any questions? Yes.
It sounds good that you're reducing the attack surface, but I think if dealing with my background in security, dealing with developers, developers like move pretty quick, they're agile. So what happens if they do want to install something? We have a package manager that security controls, or what do you see used in enterprise organizations?
Yeah, great question. I've actually got, in fact, I think this is my next slide. Hang on. So it's a great segue. Cool. This is similar to your question. I will come back, right? So common objections you get to running Distroless containers. Developers say, oh, I need to exec into my pod to troubleshoot. I need to run curl to check stuff. Now, there's quite a few Kubernetes experts in the room. What's the right answer here? Say that again. Yeah. kubectl debug. It's a fantastic command. You don't need a shell and a package management and curl with all these utilities in your actual real application, increasing the attack surface. This built-in command, kubectl debug, allows me to attach that same pod, the same namespace, but with all the utilities I need. So you kind of, that's the answer when you get this question here. I don't like, so your other question was, what if you want to add packages? We should teach people not to do that. Adding packages is drift in a container. That's an anti-pattern. You want to add something to a container, you should go back to the build process, CI pipeline, build a new image and deploy it again. If it's for troubleshooting, kubectl debug, add it on there. I'm nearly done. I do now need to just quickly talk about ChainGuard. That's kind of who sponsored me to come here. So what we do here is we want to be the trusted source for open source. Yeah, that's what it still says. We built our own Linux distribution from scratch, including bootstrapping the compilers as well. So you think Ubuntu, you think Red Hat, you think Debian, right? We're none of those. We're kind of at the same level. We build everything from source ourselves. All the open source projects out there, I think it's something like 95% of open source projects we build ourselves. We don't rely on those upstream packages or package managers. We do this with huge amounts of automation and scale. We've got over 2,000 different container images, or what you might know as a repo. So think Python, Java, Node, think Prometheus, Grafana, Argo. We've got images of all the exact same images you might be using today, but these are drop-in replacements with 0 CVEs, and they're distroless, right? No package manager shells, reduced attack surface. Our founders, just to kind of give us some credence, like these 4 people, they're all ex-Google engineers, like principal engineers there, and they kind of tried to tackle this problem, or it was 2 of them did, back in 2017. Anyone heard of the Google Distroless project? It's a couple. This was their attempt to do this when they worked at Google, but it used Debian as the backing, and they ran into a problem very quickly. They didn't control the source code. They couldn't fix things quickly. There's all these vulnerabilities and security issues in that project. So our CEO and co-founder, he also created SigStore, which is where cosign comes from. Anyone use cosign to sign their images? A few nods. So that's Dan Lorenz. He's kind of the creator of that. We sign all our images with cosign, of course. Matt Moore, our CTO and co-founder as well. So he created Distroless, him and Dan, and he also created GCR when he was at Google, so Google Container Registry. Kim is created the Salsa framework, and this is more on the security side of things. There's a whole free framework on how do you build a hardened build environment. And then VLA is actually one of the co-creators of Kubernetes, right? That's kind of part of why a lot of us here today. He was very instrumental in helping build out Kubernetes in the early days within Google. So these are all kind of our 4 founders, right? You see very heavy technical engineering background, and they saw this problem early on and kind of went out and started ChainGuard about 4 years ago. Call to action. We have a bunch of free images you can look at and use and play at home. If you're going to run containers at home, have a look. Images, ChainGuard Dev. We're doing hands-on training later on next month. If you would like to attend, there's this QR code. I'll pause here for a second. We will send these slides out anyway, so you can do it after. But if you want to come and get a bit more hands-on and learn this stuff, I went through it pretty quick. Come by, register for that, and come and spend some time with us. And then just last is just this recap, right, before we forget everything, is that so patching containers and fixing vulnerabilities is crucial, like a lot of the other security controls, but it won't protect you from the next 0 day. And so this is why I believe Distroless images should form a key part of that kind of defense in depth when you're dealing with anything that's got containers and Kubernetes. You're not running Distroless, I think you're leaving yourself vulnerable to that next 0 days you saw me demonstrate there. I think I'm probably out of time, so I'm going to stop there and finish up. So you got a question?
Hold on 1 second.
So Trendguard does their own builds. There's no CVEs when they build. Developer deploys pod with some of those builds in it. CVE gets discovered later.
Yep.
Still running that compromised code. How do you guys deal with things like, I guess, notifying of updates, etc., etc.?
Great question. There is stuff we've got. It's going to go a bit more in detail. How much time we got, Young Sam?
Technically, we're already over it.
Come see me after. I'll come and explain it to you. But yeah, keeping things up to date is critical. The key thing there I'd say is that you deploy a normal image. It's got 400 or 500 packets by default. We've got 20. So yes, we're going to accrue CVEs in runtime. You're spot on. Difference is we're going to accrue them at like 5% of the rate. So you don't need to do it, but there's a whole digester bot thing that helps keep your Docker files up to date. Cool. I probably need to finish, but please come and ask me questions after. I don't bite. Happy to try and discuss and share anything I want. And thank you for listening.
Awesome. Thanks, Andy. Yeah, our next speaker.
Years. Just a hint, there are some quiz questions later on that may refer to the content in these slides. So if you want to win prizes later on, then I might call out some bits as we go through. So just pay attention. And a bunch of acronyms, which are all exciting things to talk about. We'll dive into them as we go. Just to introduce myself and my clicker, which is not working. So, yeah. So I'm Chris Forza. I'm from a company called Nutanix. I'm a principal solution architect. I've been with Nutanix for a couple of years now, just over 2 years. I recently changed roles to be covering more cloud native technologies, hence why I'm here. Prior to that, I was covering kind of hybrid cloud and hypervisor. And before that, I've actually never been in this office before because I moved after I left, but I was with AWS for 4.5 years. I don't have all the certifications for KubeSmart yet, but I'm getting there. And prior to that, I used to work in a bank where I was dealing with cloud native technologies, building Kubernetes in the good old days of sort of the 2010s when Kubernetes wasn't winning. At that point, there were other orchestration technologies, and then Kubernetes kind of won out that battle, as it were. And that's kind of part of Nutanix's story as well. And we'll talk about that a bit later on. But I don't want to touch too much on Nutanix just now. We'll talk about that as we go. So agenda for what we're going to cover, some of the issues around Kubernetes management. We'll talk about kind of what enterprises, really anyone running Kubernetes at even more than a couple of clusters really is requiring. And then we'll talk about how you might fix that. And then we'll talk about the kind of components of fixing that and kind of build through these bits. So firstly, the kind of challenge with Kubernetes is that typically, if you're not using some kind of cluster management tool, you end up managing clusters with lots of different code, manual pieces. You might be putting some of that into configuration management. You might be using some Terraform, Ansible, some scripts, and lots of different components. And what that leads to is kind of a configuration sprawl, manual processes, and then that can give you inconsistent environments that are difficult to maintain and scale. And so what we're looking for really is building an environment that is standard so that all of the clusters have a consistent configuration. And that leads to environments that are scalable because we can start stamping those out very easily because they're a consistent configuration that we're maybe storing in a centralized place. It allows for us to have more secure environments because we know the components that are going into those environments and we can audit what happens and what happens when changes happen. And ultimately that leads to operational efficiency. So it's easier to run Kubernetes and cloud native apps and grow the clusters that are being deployed around those. And so in terms of a solution for that, really we want to use declarative infrastructure. Now it's really interesting for me talking about declarative infrastructure in Kubernetes for Kubernetes clusters. we're all kind of used to the idea of pets and cattle, and the applications. Obviously, my background is in virtualization, so VMs that are built, the very monolithic apps, and they're kind of touched, and you don't kind of destroy them, you kind of fix them and add to them as they go, and you give them names. I mean, I used to work a long time ago in a company that used to name all the servers after the Simpsons characters. And we had Homer, that was a very large file server. We had Bart, that server was always going wrong and being naughty. But we kind of kept with them, and we kind of got them working. But now with a cloud native environment, what we're looking for is with pods that we destroy, and we recreate, we deploy, we scale. When we do new versions, we kind of take those away, and we replace those pods, and we scale replicas. We don't know the names of those pods. We don't know what's going on in them. We just scales need to and destroy things and replace them as we grow. And so the idea here is that we want to use that kind of declarative idea for our Kubernetes clusters themselves. So why should Kubernetes clusters become those pets that we're looking like? The clusters themselves should start to become cattle, much like the workloads you're running on top of them. Once we've kind of got a solution that allows us to declare our Kubernetes clusters in the code, then we also want to customize that when we're deploying it. So we want to be able to update it. We want to add dynamic things. We need to add things on top of it that may be outside of what we're deploying into Kubernetes. We need things like webhook integrations, which we'll talk about a bit later on. And then we can also now start to automate the life cycle of our clusters. So we can start to automate updates for those clusters. We can heal them. We can update and roll out additional nodes and scale and add nodes without having to go in and manually kind of modify them. And so what this looks like from a tool set is using GitOps, and one common tool for that is to use Flux. And then we use something called 𝐒𝐈𝐄𝐑. 𝐒𝐈𝐄𝐑, which we'll talk about at the moment, is ClusterAPI, and that's basically making a Kubernetes cluster be able to talk to other Kubernetes clusters and know primitives that are clusters. Like we talk about pods and deployments and replica sets, we can talk about those from clusters, and we'll look at that a bit later on as well. We have an idea of a cluster class, which is kind of templating for ClusterAPI, and then we have something known as ClusterAPI providers. Ours is called CapEx, and there's some other ones here. Quiz hint is CapEx. Anyway, and then we also have a thing called Karen, which we'll talk about a bit later on, which is some of the webhook integrations. So let's look at ClusterAPI. So ClusterAPI, this is kind of cool in some respects. It's also, people sometimes worry about this. It's Kubernetes managing Kubernetes. What could possibly go wrong? But if we do it in a very constrained and kind of enterprise approach, it really helps us out with scale. So essentially, ClusterAPI adds things like cluster, machine set, machine deployment as resources that Kubernetes knows about. And we'll see this in a demo in a minute. So essentially, Kubernetes knows what a cluster is, what a machine is, as in kind of a virtual machine or a physical node. Machine sets and machine deployments, very similar to deployments and replica sets or replicas for Kubernetes and pods. And so that allows us to be declarative and be consistent for our clusters. And we can deploy clusters. You have a management cluster, which then manages other clusters and deploys them. So everything runs within the center of the management cluster to manage these other additional clusters. So let's look at what an infrastructure provider looks like. So essentially, if you think about ClusterAPI adds those resources to Kubernetes, so Kubernetes knows what a cluster is, what a machine might be that's part of a cluster. How does it then actually go out and talk to infrastructure and provision those virtual machines or physical machines that might make up part of the cloud, the cluster, the Kubernetes cluster? So what a ClusterAPI does is have infrastructure providers, and this is a specification that means when I want to go and create a machine, that I go off and I have a certain ClusterAPI provider, and that knows how to talk to the native APIs for that provider to go and build that environment for me. So a good example here is there are providers for AWS, Azure, Google, all sorts of providers, Nutanix included, vSphere as well. And this allows ClusterAPI, when you're provisioning a cluster, to go, I need a machine, I need a set of machines, I need these machines to be my worker nodes, my control plane, And this allows ClusterAPI to then go and tell the underlying infrastructures for those to be built. So essentially, a ClusterAPI provider comes with custom resources. So actually, it has things like AWS cluster or Nutanix machine that Kubernetes now knows about, but it also comes with an operator that knows when one of those is requested, what to go and do to actually deploy that. So from a Nutanix perspective, what we would do is we'll go off and deploy a Nutanix virtual machine and bring that up. And then Cloud Init is used to install and make the virtual machine become running with the code and the services that are expected to then report back into the cluster and become forming part of the Kubernetes cluster. So let's look at a quick demo of what this looks like, what this is going to kind of mean for us. So essentially here, we're using kubectl, and we can see now this machine deployment. So Kubernetes knows, or when we ask the API, it knows what a machine deployment is here. And this machine deployment has 3 machines. It looks very familiar to a replica set, same concept essentially, but this is talking about virtual machines running on a Nutanix virtualization environment. And here, if we do get, we can do machines, so we can see the machines. There's 4 machines here, 3 of those are part of that machine deployment we showed earlier on. So this is all using the standard Kubernetes and reconciliation loop that we're going to see in a minute, because now we're going to delete one of those machines. Now that means once we delete that machine, that replica set, replica set machine deployment has 3 replicas, but actually we're now 1 replica down. So the standard way that Kubernetes works and how wonderful Kubernetes is now being deployed for virtual machines. We've deleted that virtual machine, and in the background, Kubernetes is seeing that machine has been deleted and reconciling that. So the operator will be reaching out, they'll be deploying a new virtual machine, and then we'll add this into it will become part of the cluster. So get machines, we can see this machine is now provisioned, so that's a replacement. It's got a different name, obviously. Again, remembering we don't give them good names because they're just pets. We can get rid of them. Not pets, sorry, don't get rid of pets. Bad things happen when you get rid of pets. That's just cattle. So we can replace that and give it a name. And now we can do get machines again, and we can see that that machine is up and running part of the cluster. So if you wanted to scale your cluster, you just would update your machine set to have more nodes in that, and it would automatically go out and provision that. If you want to add additional clusters, you can go and do this. This is what ClusterAPI enables a Kubernetes environment to manage other Kubernetes environments. So you can start to understand how you could give developers the ability to build their own Kubernetes clusters, or you can provision Kubernetes clusters and manage them in a way that is using Kubernetes constructs and no longer having to rely on a bunch of scripts and things that don't necessarily understand Kubernetes. So we've got ClusterAPI. Let's talk about cluster class. So cluster class is a relatively new addition to ClusterAPI, and essentially, I won't linger on this too much for time, but essentially it's an ability to template clusters. So instead of having a load of clusters that you kind of define and manifest and you create and you have lots of duplicate code, you essentially use cluster class to define what you want from a common cluster, and then you can create clusters that refers that cluster class and just define the properties that are specific to that new cluster that's being deployed. And so that gives you a bunch of benefits that we talked about earlier, but in terms of the single source of truth, something you can rely on. You're only having to change a few different parameters, a few IP addresses, maybe some names and things like that. It allows it to be provisioned very, very fast, allows you version control, all the wonderful things we're looking at to kind of build this and help us scale. And if we look at here, we've got, I don't think any Kubernetes presentation is complete without a bit of YAML, but here on the left-hand side, we've got our cluster class. So another example of how this is kind of standard Kubernetes, we've got our API version, kind, metadata, spec. So if you've ever seen a Kubernetes manifest, this is what it looks like, and now this is what's referring to a cluster class. Here in this cluster class, we're defining kind of what we want the control plane to be, the template we want to use for that, the machines, other components for that. And then when we want to deploy a cluster, we don't have to define all of that again. We just define the cluster class here that we want to use for defining this cluster. You can see the classes there, and then the version we want to use, and maybe how many replicas we want, and things like that. We don't have to define anything else. All of it comes from that cluster class, so we know it's consistent in that manner. So that allows us to scale even further using ClusterAPI and cluster class as well. So this is all well and good, but it's great for consistency using cluster class, but it doesn't allow us to do much dynamic customization on top of what cluster class and ClusterAPI provides for us. So there is something called ClusterAPI runtime extensions, and the Nutanix version of that is called, with an N on the end, called 𝐿, and this allows you to customize ClusterAPI when clusters are created and different operations happen. And it does this using mutation hooks on the admission controller, and we don't have to change the cluster class. We basically watch for certain events happening, and then we will mutate them and make changes or make third-party calls. So what's really interesting about this is what we can do with this. So we can do things like before a cluster hook is happened. So the user goes to create a cluster. Before the cluster is created, what we can do, and this is some of the things you'll do with that 𝐿 does, is create config maps for some of the components that are being deployed into the cluster. So the config maps are ready once the cluster is deployed for some of the bits that are being deployed into that cluster. We can do things like once the cluster is created, we can then call back and integrate the cluster into some of our tool sets to add it into the environment. One of the cool things about this is using before cluster upgrade hooks. So we use before cluster upgrade hooks to do things like deploying a patch or making a configuration change to a cluster. If we know that there is a breaking change or something that needs to be fixed on a particular version before you upgrade to a later version. So we're kind of helping with that heavy lifting of if we need to upgrade a version or we need to change a way something is deployed. We've recently moved to the Cilium and taking the kube proxy out. So in the latest version that we will deploy before, we will do some work before the cluster upgrade to make sure that happens seamlessly. And then we can do things like before cluster delete as well. So before it's deleted, we can make sure certain things are removed and reconciled as well. So this is what 𝐿 gives us. So we use this Nutanix does. It's an experimental feature, so it's not in a production release yet, but we use it for this kind of capability. We're the only company using this at the moment, but others will come. This is something we've contributed to as well. So key takeaways from this component at the beginning is we can use ClusterAPI for collaborative cluster lifecycle management. We can use cluster class for blueprints and templating, and then we use 𝐿. So all of that together is a standardized and adaptable Kubernetes cluster. When I say us, this is all of us in some respects. You can go and build and do all of this yourself. This is all standard Kubernetes kind of primitives. There's nothing proprietary in here or nothing that we're selling or doing. This is kind of just part of what you can do with Kubernetes and managing it at scale. But what about applications and data operations on these clusters? So GitOps saves today. This allows us to start kind of doing this on a day-to-day basis outside of just Kubernetes and everything that else might be running with the cluster. So we use, and what we recommend is to use Flux, and this allows you to use ClusterAPI to manage the cluster, and there's kind of the bits we talked about earlier, but then use GitOps to manage the applications and other whatever you're deploying into the cluster as well. This means you can scale, you can have clusters, you can deploy to it in a known good state from across all of what's being deployed into the cluster. So the key components that you can use here and that we use in our products is Flux for reconciling changes within a Git repository into a Kubernetes environment. You can use Helm for application packaging and templating, and then Customize to make customizations to those Helm template applications that are being deployed. The way Flux works, if you're not familiar, Flux will deploy and run within a Kubernetes environment, and it has some controllers that are looking for changes and will help deploy things that change, say, in a Git repository. If it is a Helm deployment, then it will use a Helm deployment controller to deploy that as a Helm release into the cluster. If it's just a Kubernetes manifest or using Customize, then it will use that and deploy that into the cluster. And essentially, this means that any changes that happen within the source repositories there. So typically this is something like GitHub. If there's a change that's made there, Flux will see that change and reconcile and deploy that into your cluster. And so this means for applications, but we within the Nutanix distribution, we actually also use this for a lot of additional infrastructure components that are deployed. So let's finish up very quickly with a little bit of kind of talking about Nutanix and our Kubernetes platform. What's it take to build a cloud native platform? Really, it's 20% Kubernetes and a lot of everything else. Observability, security, application, networking, the infrastructure pieces, all of these pieces together. And so what we're looking to do at Nutanix is make that effortless. And we use a lot of the things we talked about just now, but we add a lot more to that. So we call this kind of the flywheel here. And essentially what we're doing is we're deploying Kubernetes. And the key here is this Kubernetes, it's upstream CNCF compliant Kubernetes. So we can deploy that onto Nutanix, VMware, bare metal, AWS. When we're deploying it, we're using ClusterAPI, everything we just talked about, we're managing and deploying. But we also deploy a bunch of other tools to make sure that the cluster is ready to use straight away, like DEX, which is for a single sign-on, so kind of managing security. We'll deploy Cilium or Calico, depending on the environment we're going into. We'll put traffic and MLLB into there. And we'll also put a CSI driver in there so the storage is ready and available for you to use stateful workloads. And then if you want, you can deploy all these other tools. Again, these are all just the open source versions of these tools. But we will manage the lifecycle of those for you, or our tool will. So you essentially don't have to figure out how to deploy and update these tools on their own, or how they integrate with Kubernetes itself. And when you're upgrading Kubernetes versions every 4 months, with what the impact of that is going to be. When you use Nutanix Kubernetes platform, it's pretty much one line you run, and that's an upgrade, and it will upgrade all of this to the latest version for you across the environment. And then lifecycle management support, you can come to us and we will help and support all of these components here as well. So there's a number of other things we'll do in here as well. And we'll deploy Harbor as a registry. We've got open costs for cost management, all these kind of pieces that we've got. So essentially, everything we talked about earlier on, ClusterAPI, all those kind of pieces, open source, but with NKP, we add on top of those as well, or augment those to give you real kind of scale and a real enterprise kind of ready stack. One last slide, and I said you might want to pay attention to this quiz ready, people. Essentially, Nutanix, not a lot of people have heard of us in this space. We have a history of being a distributed storage company, a virtualization company. We're a great alternative to VMware if anyone's looking for one. But in 2023, we acquired a company called D2iQ. And D2iQ in 2020 created a product called DKP, which is what's now known as NKP. So it's 5 years old or 6 years old at this point. D2iQ came from a company called Mesosphere. So if people are familiar with kind of the 2010 era, 2010 to sort of 2018, when companies like Twitter and Airbnb were trying to run at scale and understand how to do that, Mesosphere from Apache, Mesos from Apache was a way of doing that, running containers, running it at scale, very similar to Kubernetes in some respects. And so Mesosphere was a company that was formed to help manage and run Mesos for some of these large companies. They were one of the founding companies of the CNCF. And then once Apache Mesos was less in favor and pivoted to Kubernetes, that company rebranded to D2iQ and launched a Kubernetes platform. And so that's where Nutanix and Kubernetes comes from now. So it's a relatively new name and relatively sort of unfamiliar to many people, but it has a real rich history in managing containers and orchestration at scale. So with that, in summary, if you're using our products, it's 100% CNCF, so it's a lock-in. If you can just turn this off and you've still got the cluster and everything running, you can carry on doing it. If you're looking to run at scale, you want to be using things like GitOps. And we also support things like multi-tenancy, and then that gives you that kind of operational excellence and really helps you run a secure enterprise environment as well. As a takeaway, go and have a look at nutanix.com/powernative. It's a great site with lots of resources and additional pieces there. And also go and have a look at the Cluster API doc, so Cluster API book. It's really interesting to kind of learn about Cluster API, the additional infrastructure providers, how this works, and yeah, really interesting to learn about. And with that, thank you. Good luck with the quiz.
Thank you so much, Chris. Yeah, we might have got time for just one question. Anyone has any questions? No question. So excited. Want to do quiz. Before that, let's have another talk from O.
So, a very good evening to one and all present here. My name is Om, currently a Master of IT with AI student at the University of Melbourne. And today I have a short discussion on the era of resource efficient AI models. So basically this talk, I would like to start, with actually stating one of the quotes which I have felt personally while I was doing my research alongside, and goes something like this. So remember, it's not always about the most correct choice you would choose, but it's more of having more alternatives to get your task done with, having an overall benefit. Like you have to not only think about a single thing which matters. It's about many multiple things which could matter at the same time with respect to that. And let's get started. So you would just see this and you would think like, why do we need energy efficient models for the AI applications in that era of AI? So any answers, just quick. Anything's fine.
Sustainable.
Okay.
Cost of RAM.
Okay. And
We don't have enough power.
then they say that.
Save money. Latency.
Okay. Anyone else?
To reduce the carbon footprint.
Okay, that's valid. Yes. So could you, relate the most of the answers which you have said are all at the end relating to environmental sustainability. They're indirectly or mostly directly related to environmental sustainability, right? So this is what I want to address, because these days people are just making models no matter how complex they are, no matter how much energy these are being using the resources they are using, even to answer a simple query, just to tell that your coffee color is brown. Yeah, exactly. So you just ask what's the time, and your model just consumes a lot of energy just to tell what the time is, or even a more sillier answer. So that's what the other few reasons which I mentioned, majority of them are all environmental impact ones: economic efficiency, cost saving, regulatory compliance, scalability. Those other two ones are basically for you to understand that efficient models are easy to handle as well, right? They're easy to handle, they're easy to maintain. And if it causes an error, then you could go back to the model. If it has an easy architecture, you could fix them, right? You could really fix them. So that's one of the things. And so if energy efficient models are not used now at this time, it could just lead to this someday. So let's get started with the actual thing. So techniques to make the energy model efficient, or any kind of models which you would be using. So the few techniques such as pruning, neural architecture search, because for your use case, you will be using a neural model or a machine learning or AI model, which has its architecture suiting to the use case. It might differ, like some person needs a CNN, some person needs a transformer, depending on a use case, right? So these are few of the ways, such as pruning, so that you don't have to take the features which don't impact the outcome of your model much, right? So let's get started with the research topic, my research, my deep research, which I was actually doing. And it necessarily doesn't have to be a CNN, but the observation which you could take can provide a strong reference material for you, which can help you analyze what are the things we need to consider while making a model resource efficient. I have addressed energy, layer-wise energy consumptions. Why? Because when we discuss about a model, one of the most important things when we see in front of our eyes as it's architecture, you know. It's like a model on what it is built, what are the layers used in them. You should know what the model actually consists of before using the model, right? But we generally don't have the idea of that. It's like we miss out on that, or we just see which are the models which are just hyped up for a use case. Alright, we just blindly go for that. So I would say, like, this was a proposed system, and many of them are just basic ones. But I wanted to focus on model usage modules because these were the specific models which we had used initially, and these models were themselves made by companies like Google, Microsoft, Facebook, right? And these models were huge when they were built the very first time. And these are good for their own use cases. And mainly, we have tried to use all these models for a particular task so that we can assess them better for that particular task. To narrow down our search, our model compatibility testing, our model performance, and how much of the energy, time, and all that stuff they're just making use of, right? So yes, visualization model. This I will address it later because I want to explain you respect to this. Yes. So we had multiple research challenges which were so hard to understand, so hard to figure out that the code was not accepting the dependencies, the Python dependencies, the system, there were issues with that. And the code was not able to accept these models, layers and sublayers because they were so huge for it to get considered. Since the model layers and sublayers of the architectures were not getting considered, we ended up getting incorrect results. So these all results which you see are incorrect for the overall module. It's correct for the layers which are being considered, but it's not correct for the overall module because the model has more layers than these. So after 50 to 100 times of hard coding, hit and trial executions, we have faced situations where we actually bought the number of layers getting skipped to a single digit, and then we were also able to fix it to 0 layers getting missed out, which means when we have 0 layers getting missed out, our model consumption can be measured in an accurate way and the visualizations can be correct, right? So I don't want you to deep dive into the theory. Yeah, so this is the visualization. When you see that 10 internal layers were skipped, when I mean that 10 less than 10 internal layers were skipped, it means I'm talking about all the 6 modules which were taken into consideration, all the layers and sublayers which can add up to 2,500 layers and sublayers across all 6 modules, all 6 models. And for all 6 models, when overall 10 layers were skipped, this was the result, you know. So this is basically you helping you to analyze models computation power and models consumption on the basis of the resources which it has, right? And when less than 10 internal layers gets skipped, the majority of the layers get considered. These are the layers which get considered. Don't deep dive into them like finding out which layers and what layers are present in models, but this data on a research level can help you analyze which model has the layers which are not supposed to be considered, right? And we assess that with these visualizations because this is when we get 0 layers skipped. So any visualization you see in this slide is more accurate than the ones which I've shown you in the previous one. But the research gap and the challenges which we faced are the main reasons where we actually still don't remain complete. Yeah, so these are all the performance metrics and all the visualizations which help a person actually understand, a researcher actually understand what are the observations he needs or she needs to make a model energy efficient. And based on this, so I would like to say like there are many researchers, students, working professionals who have access to cloud GPU, and there are many at the same time who don't have access to any kind of GPU. So we have tried this experiment based on both local GPU and cloud GPU. And the difference was really massive in terms of not the outcome, but I mean, they were like minute differences, but they are like negligible compared to each other. But if you see in terms of the time consumed for the outcome to come, the time consumed, the dependency installment, the headache which you would need in terms of dependency installment. So there are differences between the local and the cloud GPU. You can always prefer the cloud GPU in terms of, having the dependency installment headache lowered when you use the cloud GPU. And in a local GPU, it's like you setting up extensions, you setting up multiple extensions for supporting your code, your VS code might get hanged up depending on multiple repeated extensions which you would use, right? And that's where the local GPU doesn't overcome your cloud GPU. Your cloud GPU has a more accessibility and more flexibility for you to have your extensions installed because that knows which extension you would have installed, right? So algorithm of a code implementation was something like this for research, which I won't deep dive into. And I have shortened it in these for you to understand. So I'll be sharing the slides with him. And it's already available. You can access them to the Google Drive link. So what I wanted to address that energy efficient models, basically in terms of energy, time consumed, and these are the main parameters, and power consumed are the main parameters which I would say, which a person needs to consider and have as a strong reference material for you to understand that fact. But we often realize when we do even these kind of research, for us to analyze which model is efficient, by that time you anyway end up using the GPU, which actually makes the thing in a way that you have to sacrifice some of your resources in order to find out what you actually need, right? And incomplete mission, and we aim to achieve it. But what was it? It was, as a researcher, individual researcher or student like me, I don't have access to building models such as if it were me to make models like AlexNet, VGG16, ResNet, these models were themselves in a situation where they had been on 3 to 4 weeks of continuous training on high systems, on high supercomputers or whatever which the company provides, right? And a normal student like me won't have access to such resources in making models which could compete models like AlexNet, VG16, ResNet, EfficientNet, VNode, and whatnot. So the research challenges which we face generally, so the quality issues, the resource availability, as I mentioned, the integration challenges and dependency issues, like the modules, the Python modules generally don't support, the newer ones don't support the libraries, which were actually meant to support. So you need to stick back to the outdated versions of Python to make your code work, because even if the syntax doesn't change, the dependency version changes. You have to make sure of that as well. The software and hardware dependencies again comes as a part of integration issues, which I would like to admit. And scalability and adaptability, you can have a more scalability in resource efficient models, because in a resource efficient model, if the architecture is easy, you can make the architecture complex later on to fit more in it. But if your model is already complex, to make it more complex, it doesn't work well. A limited domain specific model is one of the drawbacks of energy efficient models, because they are limited to your use case and might not be able to answer well for your other use cases. So this is a small question answer before we move on to the quiz, the final quiz. So this question doesn't have a particular right wrong answer, but I would like to ask you, in a general case, what would you suggest, which of these models will work well or better according to your point of view or your thoughts?
What would be?
And could you justify why would you choose model B and not model A?
The drop in accuracy is actually much smaller than the drop size of the model.
And was that the only reason?
Yeah.
Anyone else?
It's gonna be have less parameters. More than compared to the bigger one.
Works well. Anyone else? Yeah.
I would have chosen model B if it were 20% smaller, but I would choose model A because it's only 2% smaller. So I'd choose model A.
Okay. Okay. Anyone else?
Just gonna add, I think the question kind of depends on context as well, right?
I mean, it's just a general case.
Yeah.
So it's like personal point of view, So depends on what you would use for general case. Like it could be any situation.
So if it's a personal point of view, then definitely it's gonna be model B because personally you have less documents or, like talk about the vector database, then it's gonna take less time to process the documents and extract the documents from the multi-directional database.
Yes, but that comes with a price. It's fine to choose model B. It comes with a price of the quality outcome because some people generally they prefer more accuracy even if the architecture is small or big. They don't get it. There are many cases, many use cases. Suppose in medicine, it's more generally of the accuracy. They solely depend on accuracy of the thing. Because for MRI data sets or cancer data sets or brain MRI data sets, they generally go for the accuracy because that helps them detect the disease much better compared to them using model B because they don't want to compromise on architecture and all that stuff. So organizations when they feel like they don't want to compromise on things like architecture or the model, or if the cost which they spend on is enough to get a model with higher accuracy and higher performance metrics, they generally tend to choose that. But if there's a massive difference in terms of cost saving and if the quality of outcome is nearly the same, that's when many industries also choose ways where model B is a preferred one. And there are also industries which prefer like medicine and healthcare, they prefer model A because they find that the performance metrics is one of the most important things for them, for their aspect, for their use case. So I would like to conclude saying that students, researchers, working professionals would actually, when at times they want to build something by themselves for their purpose, or even like working in research domains, they generally don't have so much access to such resources where we could make models which could compete these models at the initial level, right? So this particular research is still in its ongoing process, and this research is mainly to provide a strong reference to people who are mainly building models for the future generations, because we need to think about the environmental sustainability. We need to be building models which are more efficient so that we can scale them later. And if a model is already complex, it will be hard to manage the environmental sustainability and also to take care of the complexity and the scalability domains. So that's how I would like to say. A special thanks to Mr. 𝐒𝐿𝐀𝐘 to give me this opportunity of making people aware of energy efficient models, and thanks to AWS for hosting us at their office today. And special thanks to each and every one of you to attend this event, taking out your valuable time and making it here today. Thank you so much.
Thank you so much. Anyone has one question? Any questions?
Any questions?
So excited. Let's do the test.
And
If no questions, yeah, we will.
feel free to connect. Yes.
All right. Are we ready to do the test? So let me get my laptop connected. Stop share. Thanks, buddy. Yeah, just to just to remember one of the price. Which one is it? Which one is your favorite one? Okay. Also, remember I said the leaderboard. I want to show you the leaderboard first. Okay, if you go to KSUG.AI/heroes, yeah, that's the community program I created. Just hold on one second. Let me share my screen. Otherwise, the people online, they want to be able to see. Where is my Zoom? Okay, it's already here. Can you guys see the screen? So the Heroes program I created basically to encourage more people to help us spread the news. Okay. And then some people actually also donate us free cloud exam vouchers. That's where we can help our community members to get certified for free. So I hope you guys can support our community program. So the leaderboard will show you, if you guys did follow us, I can see actually reacted us and Rana J, who else? I can see my friend, I can see Ash. So that's the list, okay? I want to see your name is here before you can become a winner, okay? Is that fair? Pretty simple, just a few seconds, click like, right? Okay, if you set a private, so basically, as long as you react our LinkedIn post, so AWS from kubestrong or KSUG.AI, your name will be here. You can react, you can repost, you can comment. So it based on the score, okay? Based on how much you helped us. We have a score system to say who reacted, who helped us. So you can filter even by dates, okay? So for example, for the last 7 days, you can see different people, okay? So that's the system, I spent one weekend, I joined some of the coding activity. I built this during that time, okay? So pretty interesting. So now, are we ready for the quiz time? So it does take about 15 minutes. If you haven't reacted our LinkedIn post, I can't help you, okay? But for smaller swags, the caps, yeah, everyone can get one. But for the price, like this, I need to see your name, okay? I need you guys to help us to spread this. So potentially we can get Changard and Nutanix to continue to support us, okay? So let me question.
So sorry, I think get on the.
Okay, so are you guys, let me just show you this. Can you guys see the screen? So if you scan this QR code, it will take you to our homepage, to our landing page. I'm going to show you now, okay? Actually, it will take you directly to the Heroes page, but you can either type or you can scan the QR code. And also the quiz time also from this web page. You need to click the icon, KSUG.AI. It will take you to our landing page. And from here, you should be able to see the 200,000 plus. And if you click this link, it will take you to our link tree. That's where you can find all of our social links, including our LinkedIn page. So if you scroll down, almost in the bottom. You can join us as a volunteer, as a speaker, as a sponsor. And on top of that, you can see all of our social links. So how to get to the list? As long as you can react, repost, comment any one of the three LinkedIn page. So KSUG.AI, awstronaut, and kubestrong. And then your name will be here. So while we're doing the quiz, so you need to click any one of the links. You just like, comment, repost any one of these, and then your name will be here. Okay. And if your name is not here, you can search as well. Okay. Let's say I want to search my friend. Okay. And one of my friend, he is ranking number 12. Okay. And if you want to say, what about Ronald? Okay, dude, you are only 37. Where's okay, so basically the more you react, you're helping us, the higher on the top. Okay, are we ready for the quiz? Let me just kick off. Just give me 1 second. All right, let me get ready for the quiz. I'm going to start this now. And then we should have. So can you guys see the screen? Let me see. Did I share? I didn't share the screen. If you go back here, so if I do a refresh, so we are using the Slido. So that's how you can join, okay? So you just type a KSUG.AI, or you can scan the QR code. Let me bring the QR code again. Thank you. Are you guys in yet?
Can we get the music?
Okay, I'm actually testing the new system. It doesn't work this way. No, looks like it doesn't work. Okay, let me go back here. Okay, present.
I think, yeah.
Hold on. Okay, here we go. Let's see how many people. Yeah, should we wait a few more seconds? We got a 19 right now, 20. Yeah, I'm actually also pretty new to the system. How can I get started? Did you guys all scan yet? So we got a 26, 27. Everyone good? Okay, let me come back here. Now we should be able to see. Where? How to get this? Okay. Is that present? It's not present. Join increase. How I get started? Participate. Actually, I don't know. I tried this before. So we got 30 people here, but how to move? Oh, here. First question. Oh my God, come on. Finally. So what is 0-day vulnerability? This one should be relatively easier. Yeah, let's see how many people get the correct. Wow, amazing. Yeah, we got a 92% people get it correct. So let's move to the second question. The correct answer, software flaw that is unknown to the vendor or maintainer. So next question. Oh, first of all, let's see who are the leader. So remember, we got a 2 leaderboard, okay? So Tanish, he is leading. So how to get to the top? You need to answer quicker and correct. So second question, LOTL, living off the land attacks, are attacks where? So let me actually, should we turn the lights a little bit light? So anyone get the correct? So attacks where binaries and the tools that are already installed are used. Not too bad, 88% correct. Let's see the leaderboard. Oh no, we skipped. So what is a Distroless container? Yeah, I remember Andrew mentioned this. So let's see how many people get the correct. Oh, another 88%. Awesome. So what command is suggested for troubleshooting a container running a Distroless image? Well, you guys are amazing. Yeah, let's see how many people get the correct for this question. Oh, 86. Yeah, good. If I show leaderboard, where? Okay, if I click show leaderboard, it will say who are leading. �‌𝐀𝐘 is leading right now. So next question. What is the name of Nutanix copy provider? Yeah, I saw it on the slide. And Chris did highlight that. Confused. So definitely D is the correct answer, I guess. Come on. That's the CAPX. That's the Nutanix copy provider. What does the NKP stand for? I'd be surprised if you answer this one incorrect. Wow, unbelievable. I never seen any question. Everyone get it correct. NKP has a history that relates to which Apache software foundation project. Yeah, this one looks a little bit harder. Okay, QC is leading now. It's Apache Mesos. Next question. Only 5 or maybe 6 to go. Yeah. Halfway. We are halfway. So in what year did Nigel Mansell win the Formula One World Championship? This one wasn't covered. Yeah, it's based on your knowledge. Or you can ask ChatGPT if you can ask fast. Oh, also more than half answer correctly. Not too bad. So next question. So the environment benefit of using energy efficient models of AI. Which one is correct? I think this one should be easier. Let's see. Awesome, 93% correct. So we still got a few more questions. What is the method for dropping the unnecessary parameters? Yeah, let's see which one is the correct one. Oh, 93% correct. Good job. Harini, jump to the top. Good job. Who is Harini? Oh, good job. Still 2 more questions, 3 actually. Is that 3 or 2? Only 2. Which dimensionality reduction technique was mentioned for improving energy efficiency? Actually, I don't know. Yeah. So worst case, you just tick one of these. At least you get a 25% correct. Good, PCA. Yeah, that's a correct answer. And let's verify the leaderboard. QC jump to the top again. Last question. What was the conclusion regarding local GPU versus the amount of GPU in the cloud? Let me put on the lines. Wow, 81% correct. Yeah, let's see what the final winners. So the first top winners got the choice. You got more stuff to choose. Okay, towards the bottom, you don't have many choice. Let's see who are the leader. Congratulations. Can you guys take a screenshot? Let me take one. So the problem is I want to be able to see the number 6 after number 5. Yeah. Oh, yeah, that's probably because of a free version. I want to be able to see the number 6 to number 10. Let's see. Who is QC? Oh, okay. Who is QC? Oh, someone from online. Yeah, let's see. Where? Okay, who is QC? Anyone online? I don't see anyone answering. Okay. If nobody answer, we might just skip QC. Who is QC? Let me just ask. But the problem is we want to have any digital swags to give away anyway. If you join online, yeah. So we used to have the code club, but we no longer have the option anyway. So okay, let's move to the next one. So who is Tarnish? Oh man, you just won last time. Let me come back to see what are the price. Yeah, where are the price? Okay, no need to check. Okay, can we take a photo? Yeah, sure. Come over here. Anyone can help me. It's better to use my phone so I can. Thanks, Malaysia. Awesome, yeah, good job. Should I give his name as well? Well, it's all right. Congratulations. So, people often, again, so I said, we all last time, we wanted to ask last time. So let's see what the next winner, 𝐏𝐑𝐘. Is that 𝐏𝐑𝐘 here? Congratulations. Let's see what else we have. Yeah, we got some other prize. We still have a chain guard gift card, $100, also pretty good.
Yeah. Should be gift card.
Yeah.
Yeah, should be out there.
Yeah, it's over here, yeah. Congratulations, yeah. The other camp, we take a photo.
Yeah, sure.
Do LinkedIn post, how fast the screen is. Yeah, serious. Tag a chain card. All right, congratulations. What's the next winner? Andy. Congratulations. Let's see what we have. What else we have? Do you want the book?
Sure.
Yeah, the Kubernetes book.
Yeah.
You already passed all Kubernetes certification. Why you need a book?
Just like put on my desk.
Okay. Yeah, the book. All right. Come over here. Yeah, we do a photo.
Oh, nice.
Make sure you take you do LinkedIn post and tag us.
Oh, yeah.
Congratulations, buddy. So we got let's see who is next winner. Ranaji. So why the winners every time we see the same winner? Congratulations, man. Let's do a photo. Huh? Yeah, yeah. What do you want? Yeah. Let's do a photo. So what we have is
anything.
You have a look.
You can give me anything. Hoodie, backpack.
No, they don't have a hoodie. They haven't delivered yet. Only socks or area $100 credits.
Okay.
Yeah.
So what is the chain guard mistake?
So that one was already taken.
Oh, okay.
Yeah.
Okay.
Too bad.
Then only one is pending, right?
Oh, yeah.
Yeah.
I don't have anything. Yeah, only this one. If you want to, if you want to play around the AI,
Right.
that's a good one.
Yeah, that's the only thing
Yeah.
left, right? Yeah.
Yeah.
So, yeah.
Congratulations.
Thank you.
So if you guys don't mind, come over here. We do a group photo. Okay. Thank you everyone for joining us. So just a reminder, Saturday we have another event. It's a half day. And then 12th March, we got here, same place, level 12. It's a 4-day hands-on workshop. All right, guys, come over here. Let's do a group photo. Yeah. Awesome.